This is the second video in the series, Getting to Know 3DXpert. If you have not yet watched the first video, we encourage you to do so, as this video is going to pick up where the first one left off. In this video, we will focus on getting the part prepared for printing and also building supports. And once again, we would like to thank you for taking the time to review this presentation and for your interest in 3DXpert. We will begin by applying shrinkage compensation to the part model. As each layer of the printed part cools, it will shrink. So we will compensate for this in the X and Y directions while maintaining the same Z height. Next, we will prepare the part for printing. Some part features may require us to add material for printing because we will need to machine that away afterward for a good finish. Other features may be very awkward to support, so we may choose to machine those features into the part after printing as well. With 3DXpert's full modeling capability, any required changes to the part can be done easily. In fact, the part itself could be modeled from scratch right within 3DXpert. So at this point, we're going to extrude a new object that will be included in the printing. This way it will plug that sideways hole that would be very difficult to support otherwise. And since it is a different object, we can include it in the print, but treat it differently than the part itself. Here we can assign a different print strategy. So while the part may be printed in layers of 30 micron, this plug could be printed in 60 micron. Let's look at another area of the part that requires stock for machining. And again, by treating it as a separate object, we won't need to print it in as much detail as the part itself, especially since we're just going to machine it away anyway. Let's now look at a feature called direct modeling. Again, 3DXpert can do all of this modeling because it will work with imported CAD models. This time we're going to actually change something on the part itself. We would like the ring or shoulder around the three outermost holes to be bigger. So we'll use direct modeling to offset and increase the size. And this, of course, adds more material to the printed part in those areas. We will now discuss the next big topic of this video, which is adding supports for printing. The first thing Support Manager does is help us define the overhanging areas that will require support. This will be based upon how much the machine can handle. Once those regions have been defined, they will be shown as boundaries on the part and also listed in the tree. So again, these boundaries have been created based upon knowing that the machine can handle a 45-degree overhang. We will create our first support type by working with the hexagonal shape at the bottom of the part. The option we will use for this one will be solid support. The functionality and the options available in creating supports is truly impressive. Here we can choose to build the support with fragments and control the size and gap on those fragments. We may choose to tilt the support off center, even having more than one tilt to it. For greater strength on the build plate, we may choose to use a radial tilt. Or again, to ensure that the support won't break away from the build plate, we can make the support straight and then put a skirt on it. And with all that being said, for this straight wall support, we will just simply fragment it. As we work through these different regions, we can choose to either select them from the tree or just simply pick the boundary that's been created on part geometry. So we will pick the next region at the bottom of the part, and for this area we're going to create a lattice support. So as you see here, the controls are a simple slide bar, or you can simply type the value in yourself if you wish, and then as it is throughout the system, the preview will dynamically update for the changes you make. With diameter growth ratio, it's possible for the support to be much bigger at the bottom and then branch into smaller supports at the part. That brings us to our next support type. We're going to pan over to the right and then we'll start building some cone supports. As we build supports on the three wings of this part, in actual practice we would select the same support type for each, but for this demonstration we wish to show you a variety of different support types. And again, we see a lot of options are available for controlling the support geometry. Can vary the spacing of these supports, their overall size, if we want to taper them at all. Also the option of having a sphere at the touch point and how deep that sphere goes into part geometry, or simply not having the sphere as well. It's important that we're able to tilt these cones so that we can reach into areas that are difficult to support, but at the same time we don't want to over tilt them where they themselves become an overhanging face. Once it reaches that degree marker of 45, which we know the machine can handle, you see that the line turns red, telling us that that's not going to be a good support. So finally, we determine the tilt and spacing and size that we want as we see that the support is reaching in to support that flange, but it's not touching the feature below it. In addition to automatically generating cone support, we can manually place them exactly where we wish. In this case, we'll position them on the smaller flange and show some of the options available there. We simply pick the point where we want those supports to be, and as you see, all the options are there like before. The options of tilting. Also, since there's 2 points, we have an option of doing a cross pair so that they will crisscross and support each other underneath. And this is great if we think a printed feature is going to bow or flex, and now we can use this crisscross to support it at an angle. Manual cones can be used anytime and in combination with other support types. This will bring us to our next support type, wall supports, and we will use this with a pattern. There is a wide selection of patterns available that we can pick from. We just simply select the one we want, give it the appropriate size. Do we wish to work with a hatch or fragment it? Or we have also the option of offsetting the outer boundary curve. This pattern then will be used to create supporting walls inside the boundary. And the idea of fragmenting is so that it is easier to break these supports off the part. Now that we have the pattern set, we can go ahead and start building the wall support. As with the other support types, there is a large selection of useful options available. We may wish to control the texture or pattern in the side of the walls that allows for easier powder removal. We may wish to control the teeth that hold the part down, and the size and amount of intersection that the teeth have with the part. We may wish to have a solid support at the bottom of this wall where it's attached to the burn plate while keeping the teeth against the part where they will be easier to break free. As always, there's the option of changing the size of any of these features on this wall support. Plus, just like before, there's the option of doing tilting and scaling and radial tilting so that we can work this support into difficult areas. So in this case, we may not feel comfortable bringing the support straight down and so close to the printed side of the part. With that, we can simply tilt it or shift it at the bottom, having it come in at an angle, and then keeping to the rules of making sure we don't create an overhanging support. Here you can see what the tilt looks like and also how easy it is to control the break point of the tilt. We may wish to use this support several times or in different jobs. One nice feature to 3DXpert is the ability to save these supports as templates so that the exact same support structure can be used again and again. And using templates helps ensure the repeatability of the process. With that, we're ready to move on to our next boundary. And here we're going to apply the template we just created. First of all, we'll talk a bit more about boundaries. These boundaries were created automatically, but we can manually create boundaries and we can edit boundaries as well. So first we're going to edit the boundary. We may feel that using this boundary would create supports that come too close to the printed sidewalls of the part. The boundary curves are projected down to the tray, and while working in Sketcher, we can then delete the curves that we don't wish to keep, and then create new ones using the sketching tools that you see on the right. So here I have deleted the curves closest to the sidewall of the part, and now I'm going to close the boundary by just creating a simple line across that opening edge. Once that's done, you'll see this boundary is reprojected back up to the part, and you'll see exactly where that boundary now falls on the part geometry. From the pull down, I'll then pick the template that we just created, and it will create the same wall structure that we created before. And even after having created this wall support using a template, we can still go back and edit it and change it to whatever we need. Perhaps we may choose to add tilting using radial tilt so that we have a wider base of support, or just using the tilt like we saw before, where we move it out a bit to clear the part. In this case, we would like to add a break in the tilt, and then from there, each of these planar references that you see, or you might see the point, the pink point, is a place where we can edit the scaling, where we can increase or reduce the size of the wall in that area. All the supports that have been demonstrated can be added to a template, and then a template can be applied to more than one boundary at a time. Since all the supports are done, we can now look at slicing the part. Now to do that, we want to make sure that all the objects have been assigned an appropriate technology or method. You'll note too that all the supports that we just created all automatically have a build style attached to them based upon the type of support that they are. Also, it's worth taking note that in the lower right-hand corner, you can see we've been keeping track of the material usage both for the part and for all the different supports that we just created. This takes us now to calculating the slices. The technology name and build style have been assigned to each of the objects. These different build styles are predetermined and come set up with the material. These build styles that come with authorized materials can be run as is, or going into the settings, it's possible to make some changes to this. For instance, changing the layer thickness by setting the number of microns. While making changes to build styles or creating new build styles is recommended really for experienced users, still a great deal of power and flexibility is available within these settings. This would include such things as controlling the number of contours that will be included in the print, or looking at the hatching, changing the pattern of the hatching depending upon if it's a downward facing area, middle area, or making other changes to the hatching scheme. When everything is set to what we want, we can calculate the scan. Here's a brief review of some of the supports we looked at in 3DXpert. We looked at solid support and the many options available for it. We saw the flexibility of lattice support. We took a close look at cone support, both automatic and also manually creating cones. We saw how easy it is too to create intricate wall supports. And we saw how easily and consistently supports can be applied by using templates. Thank you once again for reviewing this presentation on 3DXpert. We invite you to look for the next video in this series, as we'll be discussing analyzing slicing, nesting for printing, and estimating total print time.